Welcome back. My name is Satyajeet Sahu and we are live from BYJU'S Studio, and today we are going to see the topic primary consolidation from the subject geotechnical engineering. Yesterday we had already seen how to approach geotech subject for your GATE preparation. Today we are going to explore the topic that is primary consolidation, and for the next 6 days, that is starting from today, Tuesday to the Sunday, I am going to complete this topic of consolidation on this particular YouTube channel, every day 6 p.m. Every day 6 p.m. First of all, a brief introduction about myself. My name is Satyajeet Sahu. I have done my BTech and MTech both from IIT Kharagpur, BTech in Civil Engineering and Masters in Structural Engineering. After my BTech and MTech, I have appeared for GATE and got a good rank, and through GATE I have been selected into many of the PSUs like Indian Oil, HPCL, DMRC and RITES. I served as a design manager of Delhi Metro Rail Corporation for a period of 2 years. I have been in the field of GATE and ESC coaching industry from the last 10 years, and I have taught across the country in more than 15 states, and I am expertise in all the civil engineering subjects. So with starting on this YouTube channel, I am starting what? Geotechnical engineering, and today we will see primary consolidation. But before going into the topic, let us welcome all the participants of this today's class. So as I can see the names, okay, so welcome Nikki, Juhi, Mukul, Priya, Amon, Aftab, Neha, Krishna, Divyaraj, Sandeep, Rahul, Nikki Menon, Kriti Sharma, Samriddhi Naidu, Suranjit Saha. A warm welcome to all the participants, and I expect that more participants will come as the lecture proceeds ahead. Okay, so let us start first. Before going into the topic of consolidation, let us see what is compressibility of soil. So when I say compressibility of soil, so suppose we have a soil mass. This is what? Soil mass. So if you are applying some additional stress, what will happen to this soil mass? The volume of this soil mass will reduce. The volume of this soil mass will reduce. And this reduction in volume of the soil mass, I will call that as what? Compressibility of soil. So by definition, if you ask the definition of compressibility, what I can say? Compressibility is the reduction of volume of soil mass. Okay. So in general, I can say compressibility is the reduction of volume of soil mass. Now, in how many ways I can achieve this reduction of volume? So we will achieve this in 3 ways. Okay. What is the first way? The first way is, again, I will draw a small soil mass. Okay. So this is your soil mass. Okay. Now the soil mass will have what? Voids. The soil mass will have what? Voids. And inside these voids there will be air. So I can say these are what? Air voids. I will call this as what? Air voids. Okay. Now if I am applying some additional stress, okay, I am applying some additional stress to this soil mass, what will happen? This air will come out or expel from the voids, and due to that there will be reduction of volume. So this reduction of volume due to expulsion of air from the voids, what I call that? I call that as compaction. So as I told, there are 3 reasons for volume reduction of soil. So the first reason is what? The first reason is the expulsion of air from voids, and I call that as what? Compaction. I call that as compaction, right? Now, there is a possibility that these voids might be filled with water, right? And when that will occur? If the soil is fully saturated. If the soil is fully saturated, then what will happen? The voids will be filled with water. And after that, if you're applying an additional stress, what will happen? Now the water will come out of the voids. In case of compaction, what was happening? In case of compaction, air was coming out of the voids. Okay. But if it is filled with water and water is coming out of the voids, I will call that as what? Primary consolidation. So I can say, if I ask you definition of primary consolidation, what you will say? You will say the reduction of volume of soil due to what? Expulsion of water from voids. I will call that as what? Primary consolidation. Now, we all know, or even if you don't know, I will tell you that consolidation can be of two types. The first one is primary consolidation. The second one is what? Secondary consolidation. And it's very important that we understand the difference between this primary consolidation and secondary consolidation. Now, primary consolidation we have already seen. That is what? The expulsion of water from the voids. Now, what is there about this secondary consolidation? Now, if you continuously apply this additional stress in the soil and there is some structural rearrangement, or I can say some kind of plastic deformation or creep deformation, that is known as what? Your secondary consolidation. So I can say that under constant compression or constant load, some plastic deformation or creep or structural rearrangement, I'll call that as what? Your secondary consolidation. So it's a very important slide, I can say, and they can ask you a lot of questions from this, right? So three reasons: expulsion of air, compaction; expulsion of water, primary consolidation; structural rearrangement or creep or plastic deformation, that I will call as what? Secondary consolidation. Now, I'll give you a question, okay? You solve that question, okay? I'll give you some time, okay? You see the question and match the following, okay? So this is your question, okay? So we have list 1 and list 2. So it's a match the following question. It is a match the following question, okay? I'm giving you the options. Now see the question carefully and give me the answer. Okay, these are the options. See the options carefully and give me the answer, okay? Come on. So I'm giving you some time. Take your time and give me the correct answer. I am seeing the comment section for your correct answers, okay? So solve this. Don't be any hurry, okay? See the options properly and solve this. Directly you can give me the correct option, A, B, C, D. Give me the correct option. Give me the correct option. Yeah, many students have answered it very correctly, okay? So from this simple slide you see, we framed one question. Yes? And they can ask you objective questions like this only, okay? So expulsion of air from voids, that is what? Compaction. So A is 2. Then plastic deformation is secondary consolidation. So B is 3. And expulsion of water from voids is what? Primary consolidation. So C is 1. So your right answer is C. Okay. Now in your GATE syllabus, okay, when we are considering consolidation, the portion which is asked in majority is what? Is primary consolidation. And therefore, we will explore this topic of primary consolidation. And first of all, we'll see that what things are asked in primary consolidation. Okay. So, in primary consolidation, suppose this is a soil diagram. Okay. This is your ground level. This is your ground level. Okay. So indicate the ground level. How we indicate the ground level? By marking like this. Or suppose for fun, this is the ground. Let us have a tree here to understand clearly that this is the ground. Okay, this is your ground level. Now you see, normally consolidation happens in clay layer. So this layer you can see, which is at a particular depth from the ground level, okay? And suppose this is your clay layer. This is your clay layer, okay? Now, what is this? Tell me. What is this? Tell me. What is this indicating? Can somebody comment? What is this indicating? I'll just wait for comments. What is this? Please mention, what is this? What is this symbol indicating? Please, this will be an interactive session, so I expect the students to interact with me, okay? So I'll ask you questions, so in between also you should answer to me, okay? Yeah. This is what? This is your groundwater table. Okay, this is your groundwater table. Okay. So ground level is also known as, in short we write what? GL. And groundwater table we write as what? GWT. Now you see this clay layer is below the GWT. That means what? It is fully saturated, right? It is fully saturated. Okay, it is fully saturated. Now, if we see this, this is what? This I will call as the middle of, or I can say mid depth of clay layer. This I will call as what? Mid depth of clay layer. Mid depth of clay layer. Now what things they will ask you in the examination? That's what we are going to understand in this particular slide. Okay. Now you see, if you apply some additional stress, okay, at the ground level, how can apply additional stress? Additional stress can come on the ground level in form of what? Surcharge. If there is surcharge at the ground level, there will be what? There will be additional stress. Where? At the mid depth of clay layer. Or there might be a footing also, right? There might be a footing, right? There might be a footing also, and due to the footing load, then also there might be additional stress at the mid depth of clay layer, right? Yes. So due to footing or surcharge. Now tell me, if I lower the water table, then also there will be additional stress, right? Because we know when we lower the water table, what happens? The effective stress increases. So due to various reasons, what will happen? There will be some additional stress. Due to various reasons, there will be what? Some additional stress, and let that additional stress be delta sigma. Let that additional stress be delta sigma. Now, since there is additional stress, what will happen? The water which is there in this clay layer, what will happen? It will drain out. It will drain out. And this draining out of water from the pores, this is what is primary consolidation, right? Yes. And therefore I can say this is the basic process of primary consolidation, where due to some additional stress, what is happening? Water is coming out of the pores of soil, right? And due to this, what will happen? There will be reduction in volume. Reduction in volume. Now, if we consider this clay layer, what will happen? Can I say the volume of this clay layer, V, will be area into the height of this clay layer, or I can say depth of this clay layer, right? If capital H is the height of this clay layer, right? So the volume will be this. Now what we assume is that during the process of primary consolidation, the area don't change. We assume that the area don't change, because you see, suppose you're standing in a ground, the area is vast, right? The area is vast, but the thickness of the clay layer will be in a particular finite dimension, right? And therefore I can say this area I will assume what? This is constant. So if I assume the area to be constant, what I can say? I can say the reduction of volume will be due to what? The change in thickness of the clay layer, right? So I can say whatever is the change in volume, that will be what? Area into change in depth. So I can say that the reduction of volume of this clay layer or soil is due to this delta H. And this delta H is known as what? The settlement. This delta H is known as what? I can say the soil volume will reduce. And how it will reduce? The thickness of the clay layer will decrease. And thus, this decrease in thickness, that I will call as what? The consolidation settlement, or since we are understanding the process of primary consolidation, I will call this as what? Primary consolidation settlement. Primary consolidation settlement. And this particular thing, they are going to ask you in the examination, the amount of primary consolidation settlement. Okay, so initial part of the lecture, we are trying to understand what? We are trying to understand what portions are asked or what topics are asked from consolidation. So the first thing they are going to ask is what? To find out the consolidation settlement. Okay, and the basic process of consolidation settlement, right? Now you see, will the water in this particular pores coming out of the water coming out of the pores, will that be an instantaneous process or it will be a gradual process? Can you type in the comment section? I will wait. Tell me, will the water come out very fast, instantaneously, or it will take time? Please mention in the comment section. Please mention in the comment section that the water will come out gradually or instantaneously. Yes, the water will come out very slowly. Why? You see, the clay has very low coefficient of permeability, right? So clay has very low coefficient of permeability. So yes, the water will come out slowly. It will come out, but it will come out slowly. So it will take a lot of time, sometimes years. And that is what they are going to ask in the GATE examination, that how much time it will take for the water to come out. So we can see that this consolidation topic can be distributed into two topics. First one is what? First one is your how much it will consolidate. So the primary consolidation settlement means clay layer, how much it will settle. Yes, the delta, change in thickness of the clay layer. So this is the first question they are going to ask. And second question they are going to ask is what? How much time it will take for this process of consolidation. So, if I ask you, what are the important topics for consolidation for GATE examination, what will be your answer? The first thing they can ask is the basic process of primary consolidation, and this will be what? Theoretical. This will be theoretical, and this thing we are going to tackle it today. So we are going to study this theoretical basic process of primary consolidation. And then the next thing they are going to ask is what? The ultimate consolidation settlement, or I can say ultimate primary consolidation settlement, or I can say delta H. That how much will be the change in thickness of this clay layer during the consolidation process. And the third thing they are going to ask is what? The third thing they are going to ask is the time taken for consolidation. So I have distributed the 6 lectures. On YouTube, I am going to cover all these topics, and this is the schedule. So today is 7th of June. So today we are going to understand the theoretical concepts of primary consolidation, right? Tomorrow on 8th and on 9th, we are going to study what? Consolidation settlement and the numericals on consolidation settlement. So I can say how to find out delta H, that we are going to see on what? 8th and 9th, means Wednesday and Thursday. And then Friday, Saturday, Sunday, we are going to study degree of consolidation, time for consolidation, and numericals on time for consolidation. Okay, now these things means what? These are related to what? These are related to finding what? The time t required, the time t required for consolidation process. Understood? So this is going to be the flow of lectures, and every day they will be at 6 p.m. So let us continue our today's lecture. Now today we are going to discuss what? Tell me. Please type in the comment section. Today we are going to discuss what? Today we are going to discuss what? We have more 40 minutes remaining for the lecture. Tell me, today we are going to discuss what? Yeah, the topic, but in that topic, what we are going to discuss? Please mention very particularly. See, many times we study, we don't know what we are studying. Yes or no? Many times we don't know what we are studying. We just keep on flowing with the lecture. No, we should always know whenever we are studying a particular lecture, why we are studying that lecture, yes, and what things they can ask from that lecture, yes. Primary consolidation, that is true, but in don't give me the name of the lecture. That I also know. Yeah, that I also know the name of the lecture. In that primary consolidation, what thing I am going to teach? The settlement or time taken for the settlement? Or the process? The process, I will give you three options. Process, the amount of settlement, time taken for settlement. Tell me which one. Yeah, the process, because lot of theoretical questions are asked from the process of primary consolidation. So if you are not thorough with that, then you will face difficulty in answering the theoretical questions. Okay, so we are going to see today the theory of process of primary consolidation. So I'll start the theory portion. So I will suggest you that if you have some doubt, be ready with the doubt. I will take those doubts at the end of the lecture, okay? So that we don't spoil the flow of this lecture. So let us start primary consolidation processes. Now, we know that primary consolidation is what? It is the expulsion of water from the soil. Now suppose this is your ground level. This is your groundwater table, and below that there is the clay layer, and this is what? This is the mid depth of clay layer. So all the analysis we will do where? At mid depth of clay layer, okay? Or I can say mid depth of consolidating layer. Why I am saying consolidating layer? Because the clay layer is only consolidating, or I can say the reduction of volume is happening, right? Now in this mid depth, what I can say about this mid depth? Here there will be some total stress. Suppose the total stress is sigma T1. Total stress, right? We know how to calculate total stress. If you don't know, I will teach you in the next lectures. Don't worry. There's total stress. Now, there will be some pore water pressure. Why? Because you see the groundwater table is there. That means what? There will be some pore water pressure, right? So, if you subtract the pore water pressure, suppose that is U1, then what you will get? Tell me. What thing you will get? Tell me this. What thing you will get? If you subtract, this is the total stress, I am subtracting the pore water pressure, what you will get? Please mention. See, it will be interactive session, okay? It won't be one-way process that I am only speaking and you are not answering. So please answer. What I will get? Yeah. Suranjit has answered. Some more answers. Come on, quick. Be active on your chart section. Yes, yes, that is effective stress. Yes. So I'll get the initial effective stress. Initial effective stress. So these are the initial conditions. Now why I'm calling it initial conditions? Why I'm calling this as initial conditions? Because the consolidation has not started. When the consolidation will start? It will start when the additional stress will come into picture, right? So now it has not started. So initial conditions, I can say, we'll have this initial effective stress sigma 1 dash. This is what? Sigma 1 dash initial effective stress. And how we get? This I get from the total stress and the pore water pressure. Nice. So this is your initial effective stress. Understood? What is this initial effective stress? Yes. Now there will be some additional stress. And I mentioned you, I will get additional stress due to many reasons. Can you tell me when we will get this additional stress? Can you give the conditions? I have already mentioned before also. Can you write in comment section that what are the additional stresses which we'll get? Means due to what reasons I will get an additional stress at this mid depth? I have already explained in the initial part of the lecture. Can you mention it? Please mention that under what conditions I will get additional stress. Please mention in the comment section. Write down all the reasons. See, surcharge is a correct answer. Surcharge is a correct answer, but give me all the reasons, or you can say 2-3 reasons at least, right? Yes, we'll get this additional stress due to what? Either due to surcharge I will get, right? Either due to surcharge I will get, or if there is a footing load, right? If there is a footing or foundation, right, then additional stress or increase in stress will happen when there is lowering of water table. See, there will be many reasons, okay, but we are mentioning what? The prominent reasons. So due to these reasons there will be additional stress. Now what will happen? Now let us analyze this area. I am magnifying this area. This is what? This is the mid depth of your consolidating clay layer, right? So let me highlight this. So this is what? Suppose the mid depth. Now what will happen if you magnify this area? If you magnify this, what you will get? You will see soil particles in contact with each other, right? You will get soil particles, right? Suppose this is the soil particle like this, a big soil particle, because I have magnified this. I have magnified this, right? I have magnified this. This is the mid depth of clay layer, and these are the soil particles. Now they are looking big. Why? Because I have magnified this. Now what will be there between the soil particles? Can you tell me? What will be there in the soil particles? Tell me, in between the soil particles, what will be there? This space will be occupied by what? Because these spaces are voids, right? Right. So between the soil particles, what will be there? So this is your soil particles. These are soil particles. Tell me, between the soil particles, what will be there? Please mention. Yeah, I'm seeing that side because comments are appearing here. Okay, don't think that sir is having a notebook and seeing from the notes sir is teaching. No, comments are coming here. Please tell. What will be between? Yeah, voids filled with water. So this space, what will be there? Water will be there. Very good. Okay, this space, water will be there. Very good. Now, additional stress is applied. Now, additional stress is applied. Delta sigma is applied. Now, you see this mid depth. Tell me, in this mid depth, whose area is more, soil particle or water? Tell me, in this mid depth, whose area is more, soil particle or water? See, it is going to be an interactive session. It's not a one-way session. Okay? Tell me, in this mid depth, more area belongs to what? Water or soil? More area belongs to what? Water or soil? Tell me. Yeah, water, it's clearly visible, right? It's clearly visible that there is water. There is water. So what will happen? This additional stress which is coming, that will be initially taken by what? The water. So initially, very important point which they can ask in the objective examinations, that when additional stress is applied during the process of consolidation, who takes the load first, soil particles or water? The answer is water. because it is having more area in contact, right? So water initially takes the additional stress. Now we know that total stress, is due to soil and water, right? And your pore water pressure, this is total stress, and your pore water pressure, is due to what? It due to only water. Now load is taken by water. This additional load or additional stress is taken by water. So which will increase? Both total stress and your pore water pressure will increase. Yes? And by how much amount it will increase? It will increase by the amount delta sigma. So if your initial total stress was sigma T1, there will be addition of delta sigma, and this will be your new total stress. Similarly, the pore water pressure will be what? Initial pore water pressure was how much? U1 plus what? Delta sigma. So I'll just revise this particular thing, that when the additional stress is coming, first who took the load or stress? Water took the stress. Since water is there in total stress term and pore water pressure, both total stress and pore water pressure increased by the same amount, delta sigma. And you see the pore water pressure increased, right? Yes, the pore water pressure increased by how much amount? Delta sigma. And this pore water pressure is known as what? Excess pore water pressure. So I'll call this as UE. And what is this UE? This UE is initial excess pore water pressure. Why it's known as excess pore water pressure? Because there was already some existing pore water pressure, and due to this additional stress, the pore water pressure increased. So I am calling it as what? Excess pore water pressure. I'll write on initial excess pore water pressure, or directly I can write on excess pore water pressure. Now I will ask you a very simple question. Suppose the additional stress is, suppose I am asking a very simple question. Additional stress is 17 kilopascal. They will ask you a very simple question in the examination, that the additional stress is 17 kilopascal. Can you tell me what is the excess pore water pressure? What is the excess pore water pressure? Can you tell me what is the excess pore water pressure? Please tell. What is the excess pore water pressure? A very simple, straightforward one-mark question. That additional stress is this much, is the additional stress. What is the excess pore water pressure? Please mention in the comments. Very easy, very easy. Very easy, very straightforward question. Very straightforward question. Yes. That is equal to straight 17 kilopascal, because as I told, whatever additional stress came, that is taken by water, and both total stress and pore water pressure increased, and that increase in pore water pressure, I am calling that as what? Excess pore water pressure, and that excess pore water pressure is equal to the additional stress. Very simple. Yes. So this I can say that there is increase in total stress and pore water pressure. Right? Now tell me, by this time, has the effective stress changed? Can you comment on this? Has the effective stress changed? Can you comment on this? Has the effective stress changed? Please comment. Has the effective stress changed or not? It's a very important point. Please be active on the comment section. See, my lectures will be very interactive. My lectures will be very interactive. I want the audience to be involved always. Yes, very good, very good, very good. Students are mentioning, very good, very good. Yes. It will not change. Why? You see, initially the total stress was this. Initially the pore water pressure was this. So what is the initial effective stress? That is equal to sigma T1 minus U1, right? Now you see, total stress changed by delta sigma, right? This became the new total stress, right? New total stress. And pore water pressure also increased, and this become the new what? Pore water pressure, right? But if you find out the effective stress, what will happen? You see, the effective stress will be what? Total stress, that is sigma T1 plus delta sigma, that is total stress, minus the pore water pressure. Minus what? Pore water pressure is how much? U1 plus delta sigma. But this is in bracket. If you open the bracket, what will happen? This will be minus, this also will be minus. So what is happening? You see, this delta sigma gets cancelled, and I am getting what? Sigma T1 minus U1. This is nothing but what? The initial effective stress. So I can say by this time, the effective stress has not changed. So let me just revise what has happened. First of all, additional stress came. Now the additional stress was taken by whom? Water. Due to which total stress increased, pore water pressure increased. And that increase in pore water pressure, I am calling that as what? Excess pore water pressure, right? But till this time, the effective stress has not changed. The reason I explained just now, right? Very good. Now what has happened? You see this clay layer, okay? Again, I am analyzing the mid depth. What has happened? Total stress has increased, right? Now, your pore water pressure has also increased due to this additional stress. Due to many reasons, the reasons I have already explained to you. Due to additional stress. Now, suppose this clay layer has drainage facility. Yes, suppose this side also sand is there, this side also sand is there. That means what? It is permeable. So what will happen? Due to this excess pore water pressure, what will happen? Due to this, the water will be forced to expel out of this pores like this. Now tell me, if water is coming out due to this excess pore water pressure, will the excess pore water pressure remain constant, or it will decrease as the water comes out of the pores? As the water comes out of the pores, will the excess pore water pressure, which is UE, it will be maintained or it will change, reduce or increase, whatever? Tell me, what is the answer? Understanding the question? I will again repeat that when this expulsion will happen, when this expulsion of water from the pores will happen, then tell me the excess pore water pressure will remain constant or it will decrease. Tell me. Yes, it will decrease. See, very simple, right? It is simple. You see, you have a balloon balloon with water, okay? And suppose you allow some water to come out. Obviously, the pressure will decrease, right? The water pressure will decrease, it doesn't at the volume, right? Okay, similar way, when the water starts coming out of the pores, this excess pore water pressure will decrease and finally become what? Zero. And finally become zero. So, if there is drainage facility, is very important. See, water will come out only if there is drainage facility, right? Otherwise, how it will come out, right? So, if there is drainage facility, water will drain out from the voids of clay layer to reduce excess pore water pressure, eventually to make it how much? Zero. Now, but additional stress is still there, right? Now the additional stress will be taken by whom? Soil particle, right? Because initially the additional stress was taken by water, and due to which the pore water pressure had increased, but due to drainage, the excess pore water pressure is reduced, and what happened? Now the load is taken by whom? By the soil particle. So the additional stress is transferred to what? The soil particles, and excess pore water pressure becomes zero. Okay, now what happens? Now due to this, what happened? Let us understand. Now see, initially the additional stress came to what? To water, due to which total stress and pore water pressure both increased. Okay, this is what before drainage, right? This is the condition before drainage, right? Before drainage, this was the condition, right? This is the condition before drainage, right? And this is what the excess pore water pressure. And now the load is taken by what? Water. But if you allow the drainage, this reduces, additional stress don't go. This excess pressure reduces. Why? Because now the load is transferred to what? To the soil particle. Now this becomes zero. This becomes zero. And the additional stress is now taken by soil particle. So will the total stress change? No, the total stress don't change. It remained this only. So I can say a very important point during the process of consolidation. Because what is consolidation? Consolidation is draining out of water, right? So during the process of consolidation, the total stress don't change. Because just there is transfer of additional stress from where to where? From water to soil particles. And therefore, the stress got transferred from water to soil particle. Therefore, pore water pressure decreased. Pore water pressure decreased, but total stress remained same. Now what will happen to the effective stress? It will be equal to total stress, that is sigma T1 plus delta sigma minus the pore water pressure, that is U1, sorry, this is U1. Tell me, what is this? Sigma T1 minus U1 plus delta sigma. What is this? This was the initial effective stress, right? So what I can say? The initial effective stress increased by delta sigma. Yes, so I can say during the process of consolidation, what things happened? What things happened? The excess pore water pressure decreased, right? And effective stress increased. Understood? Now let us understand all these things I've already explained to you. Let us jot them down into points so that you can remember them. Okay? Now I can divide this consolidation process into two stages. Okay, the explanation is over. Now this is what I can say, summarization of things. So first is the initial stage. We'll have questions. Please wait till the end. We'll have questions, interesting questions. Okay? Now first is initial stage. Now initial stage is what? Before the expulsion of water. What is happening? Stress was taken by water, right? This additional stress before the expulsion means what? Before the drainage. Expulsion of water means what? Before drainage, right? Yes. So before drainage, what was happening? The stress was taken by, the additional stress was taken by water. This led to what? Both your pore water pressure and total stress increased, right? And that increase in pore water pressure, I am calling this as what? Excess pore water pressure. And this excess pore water pressure was numerically equal to how much? The additional stress, right? That additional stress which came, the excess pore water pressure is equal to this. Now tell me what will happen? The effective stress was unchanged, right? Before the expulsion of water. Total stress increased, right? Total stress increased, okay? And pore water pressure increased. But total stress remained intact, and this additional pore water pressure I was calling as excess pore water pressure. Till this time, what has happened? No drainage has happened. Okay. Now, after expulsion of water, what happened? When water drains out, and draining of water is known as consolidation, na? So I'll call that as what? Consolidation begins. First tell me, when the consolidation happened, the additional stress which was initially taken by whom? Which was initially taken by the water, it went to now what? Soil. So I can say the excess pore water pressure reduces to zero. So in this way, the excess pore water pressure reduced to zero, and I can say the additional stress is transferred to soil particles. Total stress during consolidation remained unchanged. Why? Because before the expulsion of water, that additional stress was taken by whom? Water. After the drainage, it is now taken by soil particles. So total stress didn't change. Yes, it became how much? Sigma T1 plus delta sigma. This is the total stress throughout the process of consolidation. But what happened? The effective stress increased and pore water pressure reduced during the drainage. Everyone is absolutely clear about this process or not? If you are not clear, okay, once again you can go through the video. Okay, if you are seeing this recorded, you can go through the video. If you have any doubt, okay, you can send your doubts to my number. Okay, you can send your doubts to my number. Okay, I will clear the doubts. But if you're not understanding, have a look again, because we have limited time, so I cannot explain again and again, right? So if you are facing any difficulty, then see the video again. If you have still doubt, please ask the particular doubt to this number. Okay, so let us move ahead. So we'll solve a question. Okay, we'll solve a question. Now question time. So everybody is ready, can drink water. I will also drink some water. Okay, let me have some water also. Okay, I have hidden the name so that we don't have branding. Okay, okay, nice. Now, is everybody ready for questions? Is everybody ready for questions now? Yes, very good. So this is the question. You have to arrange the following events in the sequence of happening. Means what? Which occurred first, which occurred later. Okay. So there are three options given. You see, I am not mentioning the options. Everything is them. Arrange them in the sequence of happening. Please write down the answer. Please write down the answer as ABC or BAC, whatever you want to do. Please write down the answer. So during the process of consolidation, please mention the order of happening. Please, please, please. Somebody is trying to catch a cab. Who is trying to catch a cab? Obviously, I will catch a cab after the class is over. Oh, that is the answer. Okay, that's the answer. CAB. Cab. Okay. The cab calls have gone high. Okay. So, therefore, I am able to see everywhere cabs, because I am coming by cab to the studio. Okay. So, cab is the answer. Yes. The load is first taken by what? Water. Yes, the additional stress was taken by water. Yes, C. And then it was happening. What was happening? Drainage of water was happening. And when the drainage of water was happening, what was happening? Your load was now transferred to what? Your soil particle. So CAB. So such kind of theoretical question can be asked to you in the examination, and therefore you should be thorough with the process. Let us solve some more true and false questions, because we know that in our objective questions they ask you questions like which of the following statements are true, which of the following statements are false, or which of the following multiple statements are true or false. So let us solve such questions. The first question is, so you have to mention true or false. Don't write full true. Don't write full false. You can write T for true and F for false. Okay. The first statement is, during consolidation, effective stress is unchanged. So please mention it is true or false. Please mention. During consolidation, effective stress is unchanged. Please mention true or false. Please write T or F or true or false. Don't write yes, no, I'll get confused so many things. Okay, true or false. So many confusions. Effective stress changes. So this statement is false. You see, during consolidation, what is consolidation? I told you, consolidation means we are referring to primary consolidation, right? So primary consolidation means what? Expulsion of water. So when the expulsion of water is happening, what is happening? The excess pore water pressure is decreasing. So effective stress increased, right? So the effective stress increased from initial effective stress to what? final effective stress, that additional stress came into picture, right? So statement is what? This statement is false because during consolidation process, effective stress, what? Increases. Very important point. You see, therefore, I explained the theory in details because if you are not very thorough with the theoretical portion, you will commit mistakes. Let us say the next question. During consolidation, pore water pressure becomes zero. Please write your answer. Now read the question very carefully. Sometimes you get jumbled with the words, right? Sometimes you get confused with the words. Oh, what is this? What is this? Read the question very carefully. Don't be in any hurry. During consolidation, pore water pressure becomes zero. Please write true or false. Don't write Rahul, yes, no. Please write true or false. Okay. True or false? True or false? Okay, many students are getting mixed answer. The answer is false. Pore water pressure don't become zero. Excess pore water pressure becomes zero. You see, initially there was some pore water pressure, right? When the additional stress came, there was development of excess pore water pressure, right? Right? And this become the new pore water pressure, right? Now when there is consolidation, means what? When the water drains out, the excess pore water pressure became zero. This term becomes zero. But there is still the initial pore water pressure, right? So pore water pressure don't become zero during consolidation. Very important point. And you might commit mistakes in this, right? That pore water pressure don't become zero. The excess pore water pressure becomes zero. You see, such a beautiful question, right? And you get confused in such kind of questions and you commit mistakes because you are not thorough with the process of consolidation. But if you are thorough with the process of consolidation, you will not commit such mistakes. Very good. Understood this particular thing? Okay, so I twisted the question a little bit so that you get the correct understanding. Okay, so I can say during consolidation, excess pore water pressure becomes zero. Pore water pressure don't become zero. Can I say pore water pressure reduces? Yes, yes. The pore water pressure reduces. The excess pore water pressure also reduces. But the excess pore water pressure reduces to zero and the pore water pressure reduces to what? The initial pore water pressure. Understood? Very good. Let us see the next question. Okay? What is the next question? The next question is, during pore, I just gave the answer for this, but still, during consolidation, pore water pressure reduces. Please tell the answer. This is easy one for you now, right? This is easy one for you. Yeah, please fast. Yes, this is true. During consolidation, pore water pressure reduces. Yes, just it don't become zero. But excess pore water pressure reduces and becomes zero. So this statement is true. Very good. Let us see the next statement. During consolidation, excess pore water pressure reduces to zero. This question is very easy now. See, this question is really easy now. Still true. Yes, this statement is true. And this statement is true, right? Yes, this statement is true. Understood? So such kind of many true and false questions can be framed. Okay, such kind of many true and false questions can be framed, or theoretical question can be framed from this particular portion of process of what? Your primary consolidation. Now, before ending this class, I will introduce two more terms. Okay, and from tomorrow we will go into what? The consolidation settlement. Okay, so two more terms I will introduce. The first term is what? Normally consolidated clay. Okay, the first term is what? Normally consolidated clay. What is this normally consolidated clay? You might have heard this term a lot. NC clay, right? You might have heard this term, what? NC clay. Okay, so what is this? Let us understand. Suppose this is again the soil layer, this is the ground level, this is the groundwater table, and this is the clay layer. This is the clay layer. Now, suppose you are plotting the effective stress. You are plotting the effective stress at the mid depth with time. Okay, with time means suppose from long time you are plotting this effective stress. Where? At the mid depth of clay layer. So will the effective stress remain constant or it will change with time? Tell me. Will the effective stress at the mid depth of clay layer remain constant or it will change with time? Tell me. And time means what? Long time, years, takes years together. Okay, suppose 500 years, 600 years, 1000 years. Okay, tell me, will the effective stress change or not change with time? Yeah, it is supposed to change, right? There might be erosion, there might be deposition, there might be lowering of water table, there might be some construction, there might be some, we are destructing a structure. Many things can happen and the effective stress can change. So if you are plotting the effective stress at the mid depth of clay layer with time, you might get various plots. Suppose you are getting a plot like this. Okay, you are getting a plot like this. Okay, and suppose you are seeing the effective stress today. So suppose this is today you are seeing, okay, so this time is suppose today's time is what? Suppose today's time is 7th of June, right? 7th of June 2022, and suppose the time is how much? 6:56 p.m. 6:56 p.m. you are seeing, okay? Okay. Now you see, this will be known as what? This I will call as what? Sigma dash, that is present effective stress. Can I say this is the present effective stress, right? It is the present effective stress, right? It is the present effective stress, right? Okay, very good. Now, this I can tell as what? This I can tell as what? This value I can tell as what? This I can tell as maximum past stress, right? Because you see, any time before this is past, right? This is past, right? So this I can say is what? The maximum past stress. And this maximum past stress, I will write a term sigma naught dash. And this sigma naught dash is also known as what? Pre-consolidation stress. It is also known as what? Pre-consolidation stress. Now tell me, from this diagram tell me, which one is more? The present effective stress is more or maximum past stress is more? Please mention. Which is more? The present effective stress is more or the maximum past stress is more? Please mention. Yes, from the diagram it is quite clear that the present effective stress is more. So if the present effective stress is more than the pre-consolidation or the maximum past stress, that particular type of clay I will call as what? Normally consolidated clay. So if somebody asks you, what is the definition of normally consolidated clay? The answer is very simple. You see the present effective stress and compare that with the maximum past stress, also known as what? Pre-consolidation stress. If the present effective stress is more than the past maximum stress, or I can say the pre-consolidation stress, I will call that as what? Normally consolidated clay. So, if the present effective stress is more than the maximum past stress, I'll call that as what? Normally consolidated clay or NC clay. Now, can I say that if I see the diagram, can I say the soil is experiencing this stress first time in its history, right? Right? You see, has it experienced this stress before? No, right? No, because this is the highest stress. Currently, it is experiencing the highest stress. So I can say it has never experienced that stress before. And therefore, it will be more compressible. Okay, it will be more compressible. Okay, it's very simple. It will be more compressible. I'll give you a small example. Okay, suppose when handling stress, exam stress, okay, when you feel more stressed, in the first semester or in your fourth or fifth semester, tell me, when you feel more stressed, initial semester, first year or second year around, tell me, when you feel more stress, when you feel more stress, first year, when you first time enter the college, or when after giving many semester to the semester is over, when you feel more stress, tell me. First year you feel more stress because it is happening for the first time, right? You are entered the college, you are first time experienced to semester system, so many people, professors, labs, this and that assignment, right? So when you are experiencing it for first time, then what? You are affected more. But if you have experienced something before, then you will not be affected so much, which happens in the subsequent semester. So, if the soil is NC, if the soil is NC, means it is experiencing for the first time, means what? Your first semester, right? Then it will be more compressible, okay? It will be more compressible. So, soil is experiencing this stress for the first time in its history. So I can say it will be having more compressibility effect. It's a very important point. Everybody understood the example of first semester and the subsequent semesters, right? See, every time you experience the stresses, no problem. But when you are affected more in the first one because you are experiencing for the first time. Okay, so NC clay, since it is experiencing the stress for the first time, what happens? It will be more compressible. Now, what is the over consolidated clay? What is over consolidated clay? Now students who are thinking that sir 7 p.m. is over, we'll just continue for 5 more minutes. Okay, we'll finish in 5 minutes. Now what is this over consolidated clay? OC clay. What is this OC clay? Now again I will plot the effective stress at the middle of the clay layer. Okay, and suppose I'm getting a plot like this. I'm getting a plot like this. Now see, this is the present stress, right? You see, this is the present stress, okay? Suppose this is sigma dash. And you can see that this is what? The maximum past stress, right? This is the maximum past stress. Now you see, the present stress is less than the maximum past stress. That means the soil is not experiencing this present stress first time in its life, right? It has already experienced this stress and experienced more stress. Now, tell me, will the soil be more compressible compared to NC or less compressible? Please mention in the comment sections that in this particular soil where the present stress is less than the maximum past stress, is less than what? The maximum past stress. Tell me, will it be more compressible or less compressible compared to NC clay? Less compressible, very good, because the soil has already experienced. Yes, the soil has already experienced. Similar to what happens in third and fourth semester. In third and fourth semester, some students start giving knowledge to everyone. Okay, like this knowledge. Don't worry, everything will be fine. They give that knowledge to first years. Don't worry, everything will happen. Semesters will go. Yes, that happens. So that means a student in the third or fourth semester is a OC clay. Yes, is the OC clay. Why? Now don't take it literally. Now don't go to your senior and tell that, okay, sir, are you OC clay or I am NC clay? Don't. This is a comparison. This is an analogy, right? That when the present stress is less than the maximum past stress, okay, that is OC clay, and soil will be what? Less compressible, because soil is not experiencing for the first time. Okay. Understood? So less compressibility, and I can say recompression. I will call the compression in over consolidated clay as what? Recompression. Why? Because already it has faced, now it is getting again compressed. So recompression. Now tell me in general you tell me which thing is appearing more strong, tell me. OC or NC? tell me which thing is generally appearing more strong, NC or OC? First year student or third year student? No, it is not an analogy. Don't take it literally. Don't start a fight between first year and third year students. Just an analogy. Okay. Now tell me, which clay is more strong? Or you can say is less compressible. Less compressible means what? It is more strong kind of thing, right? It is more strong kind of thing. Yes? OC. OC. Yes, OC. So this difference which I am now writing down is very important and you should know this, okay? For the NC clay, it is experiencing the present stress first time. But for the OC clay, it's a repeated experience because it has already experienced. Here, the present stress is less than the maximum past stress. Here, the present stress is greater than the maximum past stress. So, for the NC clay, it's a first experience. For the OC clay, it's a repeated experience, right? Then, for NC clay, I will call that as compression because it's happening for the first time. But for OC clay, I will call it as what? Recompression because it's not happening for the first time, right? Now, more compressible, NC clay, over consolidated clay, OC clay is less compressible. Now, when I compare stability, since OC is more strong kind of thing, so it is more stable. Now, compare shear strength, OC is having more shear strength. Okay, I am comparing bearing capacity, then OC is having more bearing capacity. Now, tell me, if I ask objective questions, I will not ask, if they ask you in the examination, can you clearly write true and false statements or objective questions from NC clay and OC clay? Tell yes or no. Will you be able to answer all the questions that which is having more bearing capacity, which is having more stability, which is having more shear strength, which is having less compressibility? All those questions you can answer or not? Yes, you can answer. Now you can answer very easily. Just remember, OC is sort of what? OC is sort of more strength. It is having more strength, right? So I can say more stability, more shear strength, more bearing capacity, but less compressible. See, if something is having more strength, it will be less compressible, right? Yes, it will be less compressible. So all these theoretical questions can be asked to you in the examinations and you should be absolutely clear about this. Now last thing of today's lecture, that is what? Your over-consolidated ratio. What is this? This is the maximum past stress. That is what? Your pre-consolidation stress by present stress. Now tell me, for normally consolidated clay, NC clay, tell me, OCR will be more than 1 or less than 1? Tell me. Over consolidation ratio, tell me, will this be greater than 1 or less than 1 for NC clay? They can ask you in objective questions. Tell me, it will be more or less? Very straightforward questions which they can ask in the examination. Please tell. Yes, very good. You see, in normally consolidated clay, the present stress is greater than equal to the past stress. That means this denominator is more or equal to the numerator, right? So denominator more means what? The ratio will be less than equal to 1, right? So I can say very important point that OCR for NC clay will be less than equal to 1. You see, so many objective questions we have seen today, right? And for over consolidated clay, OC clay, this will be what? Greater than 1. Why this will be greater than 1? Because your present stress is less than the past stress. The present stress is more than the past stress, less than the past stress. So present stress is more means what? Means less means what? This denominator will be less. Denominator less means what? Ratio becomes more than 1. Okay? Thank you, AutoCAD world. Okay? So if you have not seen the lecture, please see the lecture again. So this concludes our today's session. In today's session, we saw what? The basic process of consolidation. Okay? We also saw what is NC clay, what is OC clay, and we also saw this term what? OCR. Very simple. Suppose a question is asked to you that maximum past stress is 180, right? And present stress is 240. That means OCR will be how much? OCR will be equal to your 3 by 4 that is equal to how much? If you divide by 3 by 4, yeah, if you divide by 60, that is 0.75. So such kind of objective questions, okay, such kind of objective questions, okay, you can easily answer if you have seen this particular lecture. Understood how we are finding this OCR? Yes, how we are finding this OCR? It's clear. Now coming to the future classes. Coming to the future classes, let us just see that what is there for the future classes. This is what we have studied today. Okay. I have mentioned about the future classes. Let me just take you that slide. Yes. Yes. So tomorrow we are going to see what? How to find out the consolidation settlement. That means what? How to find out the delta H. Lot of questions are asked. Okay, lot of questions are asked in delta H. We'll see the compressibility parameters like what? We'll see the compressibility parameters like what is coefficient of compressibility, what is coefficient of volume compressibility, okay, what is coefficient compression index, recompression index, and how to find out the settlement using those compressibility parameters. Thank you very much. This is Satyajeet Sir, and thank you very much for attending the session. Goodbye.